There's another way, another syntax if you like, for writing partial derivatives. We know that that if we've got a function of two variables, so x and y, that we've already seen that, say, partial derivative of f with respect to x, that can be written, another way of writing that, it will be just f with a subscript x, like that. So if we wanted the partial derivative of f partial squared of with respect to y with respect to x, the second derivative, so we're firstly doing, don't forget you work backwards here, so we want the partial derivative with respect to x, and then when we get that answer, we're then going to do the partial derivative with respect to y. So that could be written like that. So when it's a subscript, it means you've got to find the partial derivative. So let's look at an example. If f of xy equals sine of x squared plus 3y, find second derivative with respect to y with respect to x, and second derivative with respect to x with respect to y. Okay, so we'll do the first bit first, and we want the partial derivative with respect to x. Now in that case, y is going to be a constant, and if y is a constant, then that will be regarded as a constant. It's a chain rule question here, so we've got a diff in and diff out. When we diff in here, if y is constant, the derivative of x squared plus a constant will be just equal to 2x. And then when we diff out, it's just like finding the derivative of sine. The derivative of sine is cos. So that's the partial derivative of this function with respect to x. Now, having done that, we want to find, now another way to write that would have been f y x, and this is f x y. So I can say that now we want to find with respect to y. So I've got to find the derivative of this with respect to y. The 2x is a constant, so that's just like a constant out there. So the 2x is a constant. With respect to y, once again, we've got a chain rule, so I've got to find the diff in. When I diff in the bracket, I get a 3. So this is a constant. And then when I diff in the bracket, I get 3. The derivative of cos will be negative sine of x squared plus 3y. And when I knock this into a bit of shape, 3 times 2 is 6, the negative can come out front, negative 6x sine of x squared plus 3y. Okay, so I've done that one. Now I'll do this one. So I've got to firstly do the derivative with respect to y. So partial derivative with respect to y equals, now with respect to y, I diff in, and the derivative in will be just equal to the 3, because the x squared is like a constant, derivative of constant 0. And when I diff out, I get cos of x squared plus 3y. So that's the partial with respect to y. Now we're going to do partial with respect to x of this. When I do the partial, the 3 is a constant, obviously. When I diff in with respect to x, now that's a constant, so the derivative that'll be 0, but the derivative that'll be 2x, so it'll be 3 times 2x. And then I diff out, the derivative of cos of something is negative sine of that something. and that's a multiply there, so it's 3 times 2x times negative sine of that, so 3 times 2 is 6, bring the negative. So I've calculated that, and you can see that they marry up with each other, and in most cases that will be the same, that if you find the partial derivative of x first and then do the partial derivative with respect to y, it'll be the same as doing the partial derivative of y first and then doing the partial derivative of x. And don't forget that that is f of yx, and this is f of xy, not of xy, but partial derivative. You work backwards, it'll be do y first and then do the x second.